Hey, it's Dr. J. Section 3.4, Composition of Functions, Part 2. Example 1. Let f of x be 7 minus the square root x squared plus 1, and g of x minus 5. Find the composition fog of x and evaluate fog of -1. So that is the question. It's a continuation of what we were doing in part 1, so I'm just going to jump right in without too much additional information. Fog means take the function f and compose it with the function g. So watch this very, very closely. The function f looks like 7 minus the square root. Remove the x and replace it. So this argument here, also known as the empty parentheses, refer to that as the argument of the function. The argument is no longer single variable x. It is now going to be replaced with the function g of x. So in the argument, we're going to input x minus 5. Simplify this if possible. We'll go ahead and do a mild amount of simplification. That'll be x squared minus 10x plus 25 plus 1. So our final answer is 7 minus the square root of x squared minus 10x plus 26. Now we're going to evaluate it for the second part of the function. We're going to take the result from the first part and replace our x's with -1. So we have 7 minus the square root of 1 plus 10 plus 26. 7 minus the square root of 37. This is what we call the exact value. It would have been nice if we would have got the square root of 36. So maybe you'll get lucky and you'll get a nice perfect square. If it's not perfect, you can just leave it as the exact value, or you can approximate if instructed. I'll tell you if I want you to approximate. For this example, I'll give you both versions of the answer. For the exact value, we're done. 7 minus the square root of 37 is the result. For the approximate value, we'll do, I'll do the square root of 37 first, and then I'll subtract 7. So we're going to get 0.91723. So that is 0.91723. Typically, I like it around to 4 decimal places unless instructed otherwise. So we look at the 5th decimal place. This is what we call the dictator. If the dictator is 5 or greater, we use the 5 or greater rule. If the dictator is greater than 5, we round the next digit up. If the dictator is less than 5, which it is in this case, we simply throw them away, and that becomes our answer, 0.9172. This is the approximate value. Okay. So this example really just kind of picks up where we left off in part 1, although for the rest of this lesson, part 2 is going to be quite different than part 1. We're going to be asking some questions involving graphs and tables of values, as well as finding the domain and range. So take a good look at this example to make sure you understand the basic technique. And next we're going to look at some tabular results. So when a function is given algebraically, as this example was, you solve the entire problem. You evaluate and simplify using algebraic techniques that we've been studying for months now, a couple months now. We have another way of representing a function, a tabular form, example 2. Use the tables to find the values. Now for this example, I've combined the two tables together in a horizontal fashion. I'm making a table for f of x and a table for g of x. This is sometimes referred to as a space-saving table because you can fit it all horizontally and it takes up a lot less space on my board. So my values for x are -8, -6, -4, 1, 2, 6, 11, and 14. The only limitation to a tabular form, this is what we call tabular form, is you can't go outside the table. So I have no idea what's going to happen when x is 15 or when x is 16. Or we also can't interpolate between the values. So I don't know what's going to happen at 12 or 13 or 7, 8, 9, and 10. So tabular forms are limited only to the values that exist in your table. So these are the function values for f. And the function values for g. So let's evaluate several different versions. We'll start with fog of 11, fog of 14, and we'll do a couple Goths as well. Remember yesterday we learned about Goths. Goths is just the reverse composition, so we'll do Goth of 1 and Goth of -4. Alrighty then. So recall the definition of a composition. Fog means to take the value of G after you've done the value of, excuse me, I have to say that again. You're going to take the value of F after you've taken the value of G. So you need to do the inside first. We're going to find the value of g11, g of 11 first. So we find the function g of x. We find the x value of 11. This value, 1, is g of 11. So now we're simplifying this to be f of 1. So now we go to the value of 1 and we plug it into the function f. F of 1 is 2, and so the final evaluation is 2. Let's see, is it fitting on the screen okay? See if I have to adjust my camera to make sure you can see that all good. I guess you can call that part A. All right, part B, fog of 14. So take the function of f after you've evaluated g. So I sometimes read fog as f after g. I just want to start over again here. So we start with g of 14. So the function g over 2x equals 14. Coincidentally, the x and the g of x are both 14. So now we are just evaluating f of 14. So now the f function is going to stay at 14, and that's going to give us a value of 11. Calculator is not needed for this problem. For the next two parts, we'll call this part C and part D. We're going to do it in reverse order. So we're going to do G after we've evaluated F. All right, it's getting kind of messy here. So f of 1 first, so that's our initial value. So we find x equals 1, and we find the f value. So f of 1 is 2, so this value becomes 2. So now we're evaluating g of 2. So now we find the x value of 2, and the corresponding g of 2, if x is 2, g is negative 6. So this value equals negative 6. At this point, I typically ask, are there any questions? But under the given circumstances, I'm just going to continue the last example. So g of f of negative 4. Clean up our mess a little bit here. I guess you don't really have to clean up your mess. You can just jump into the next problem. But I'm going to clean it up a little bit for your benefit. So f of negative 4. So we go to x equals negative 4, find the f value. The f value is negative 8. So f of negative 4 becomes negative 8. And then we find our g function at negative 8. And that gives us negative 4. So that is the tabular form of evaluations. Now keep in mind, I can only evaluate values that exist in the table. So if I were to ask something like, so FYI for your information, if you had something like, what's fog of 3? F of G of 3. Yeah? This would mean that x is equal to 3. X is equal to 3 is not in the table. So this does not exist. If the x value that you are inputting does not exist in your domain, this is what we call a restricted or a finite domain. We cannot go outside of this table unless we had some other information that would give us a clue as to what would happen when x is equal to 3. As this function is currently given, or as these functions are currently given in tabular form, there is no x equals 3, and so the answer would be DNE. That's just for your information because this might happen in future problems. I wanted to use this opportunity to say that now. We don't always use the space-saving version of the tables. Sometimes we use a much longer version of the table. The vertical version is not very space efficient. The vertical version. It's going to play out the same way. Second to finish the table. And we'll do some evaluations. So A, evaluate f of g of -1. B, evaluate g of f of 1. C, evaluate f of g of 2. And D, evaluate g of f of 4. And right away, you notice that -1 is not in the domain. This is our domain here. And -1 is not in the domain. Of either f or g. It's in neither domain. So this cannot be evaluated. The answer is DNE. For part B, well, 1 is in the domain. X equals 1 is in the domain. This is G after F, so we're going to do F first. So F of 1 is 9. Right. But 9 is not in the domain. When you come over here to G, it's in the range of G. These are your range values. These are your domain values. So we have no 9 is not in the domain because our table stopped at 7. So unless we have some more information to tell us what's happening at 9, this is again DNE. So the first two answers come out to be DNE. Let's hope that doesn't happen to all of these. Let's try the next one. So now G of 2. Let's come over here and find what G of 2 is first. G of 2, use the G function. G of 2 is 6. So now we are calculating F of 6. G of 2 becomes 6. All right, so now we're doing F of 6. So come over here. You look at your domain. Oh, 6 is in the domain. Good. And now we're using F. F of 6 is 3. And so the result is 3. Similarly, for the last part, this time it's G after F. So F goes first. Let's figure out what F of 4 is. F of 4 is 5. So now we're evaluating G of 5. Come over here. G of 5 is now 7. So we're running into some domain issues here, and that's intentional. That's to lead us to the definition of the domain of a composition. The domain of fog is equal to the set of all x in the domain of F, in the domain of G, such that G of x is in the domain of F. In other words, you first must be in the domain of G, that's like example A, and then your image, G of x, must be in the domain of F, otherwise you end up with a does not exist value. Similarly, the domain of Goff is the set of all x in the domain of F, such that F of x is in the domain of G. So part A and part B both came out to be DNE because their values were not in the domain of the composition. So for part A, it was domain of fog. And for part B, it was the domain of the Goff. And in both cases, we ended up with a value that did not lie in its respective domain. Whenever that happens in your homework, you can just enter DNE as the result. I will hang on to this definition here for the next example. Example 3. Example 3 is a algebraic example, so I'm going to give you a formula. You might recognize this from part 1. F of x is 1 over x minus 6, and g of x is 3 over x plus 6. Evaluate fog of 0. So we're looking at this fog. 0 must be in the domain in order to evaluate it. So if we try to evaluate g of 0, we immediately notice that g of 0 is 3 over 0 plus 6, which does not exist. So this means that 0 is not in the domain, and so this result does not exist. Similarly, if we've evaluated Goff of 6, when you try to evaluate 6 into the f function, f of 6, 1 over 6 minus 6, which is 1 over 0, which also does not exist because it's not in the domain of the Goff. And so this is also a does not exist. The next example is a